Get started. Good day, and welcome to Africa Teen Geek. This is the Digital STEM School. So, if you have just joined in, this is the grade 10 physical sciences class. I hope that everybody is well and happy Monday to everybody. It might be a bit chilly today, but I'm glad that you guys all here for our grade 10 physical sciences. Today, indeed, it is the 20th of July 2020, and we're just doing some revision work for representing chemical change. And I've got some interesting information that I'd like you guys to know on Wednesday, the 23rd of, what is it, the 22nd. I'm just trying to get the proper times for you guys. On the 23rd of July, we are going to have a little mini assessment. Don't get nervous. This is all just to test your mind. So what we're going to do, we'll have a grade 10 physical sciences term 3, sort of like an examination, right? So which means that you're going to be, I'm going to give it to you on Wednesday, and then you guys are going to work on it. Guys, please don't cheat yourself. Try your best to do the questions without actually referring to the textbook. And then after that, the next day we're going to do those problems and we'll do it as revision again, okay? So that's what we're going to be doing. It's an assessment week this week. You'll also hear it from your other classes. So every day there'll be a certain subject that is being assessed. And Wednesday, it's going to be physical sciences. So guys, get your papers ready. Make sure that you understand everything that we are doing because this is going to help you. But I hope that you guys are in line with representing chemical change, which is what we've been doing lately. And we've already done the quantitative aspects of chemical change, and we've done the physical and chemical changes. So tomorrow, maybe I'll see you, maybe we can do a revision of the other two as well, so that on Wednesday, when we do the assessment, you guys are ready to do it. Okay. So that's what's going to be happening this week, and I hope that you guys will be looking forward to it. Okay, reminding you guys on where we are with the caps, and we are right now, we are on chemical change, we're doing chemical change. So what they've done, they've taken all chemical change and grouped them together. As you can see, physical and chemical change, representing chemical change and quantitative aspects. They've been grouped together to give you guys your term 3, okay? And another thing you guys have to know is that the the exam is only going to be one paper, so it's not going to be like all the other term years where there's 2 papers. This year you're going to have only one paper, so that's why we want to do all of this revision work in order for you guys to understand. Guys, the aim in this classroom is for you guys to understand. So please make sure that if you do not understand something, you send a chat, and I'll go back and try and explain whatever it is that you're getting stuck. But I hope that you're coming along just fine with representing chemical change, because we've done a whole lot of problems. You know, we've been working at problems since last week, but today we're going to be doing some more revision problems, chapter summary, etc. Okay, so I hope that everybody is ready for that. Okay, then moving on. Okay, like I mentioned, for term 3, reaction in aqueous solution has been removed. So if you do have that topic and you're planning on doing some revision on that, just cancel it out. It's not going to be count for your end of the year exam. So make sure that you have done that, because soon, immediately after we do our assessments, guys, we're going to move to term 4 work, because we're just trying to finish everything so that you guys can know all you have to know, and after that we can start doing previous exam papers, etc. Okay, this is what we're not going to do this year, which is a chemical system. It's going to count 0%. So if you have that on your study timetable, make sure that you remove it, and it's not going to count this year. Okay, so it's very important to make a reference to all of the stuff that you're going to be doing this year. And there's just this one experiment that I want to have to do, because it's almost in every book, and I just want us to read through it and just see basically a general an imagination of what it's like to have a general experiment. This one it's a relationship between product and reactant. Okay, reminding you guys that I usually work on the Siyavula and the Study and Master textbook. So if you have either or, you can use those textbooks. And as well, any other CATS approved textbook can be used in this classroom. And you can ask any question, whatever I'm reading, wherever you're getting stuck. Okay. So in this experiment, it says they do the relationship between product and reactant. Remember, we've already studied that for an equation to be balanced, it means a number of atoms need to be balanced on that equation. Because you can't get an equation only to find that it's not balanced, which means that it's not going to be a valid chemical reaction. So what happens in this chemical equation? We need to balance the number of atoms. And how do we do that? We add the number of moles, right? Which is the big number in front of your element or compound. So that is the one thing that you can control, but you cannot change the small letters on your figures. For example, this one, you can't change. You can't change this H2SO4 and make it H3SO4 to balance it out, because now you are changing what you are changing the name of the substance, and it's no longer the substance that you were balancing in the first place. So that's why you can just add the number of moles, which is the big number in front of the letter, and that's how you balance it out. So it's all a bit of maths, but it works out. So once you get a hang of it through constant practice. So here they say we're going to investigate the relationship between the amount of product and the amount of reactant. So these are our experimental equipment that we have. We've got our flask, we've got our measuring cylinder, water bowl. This is our water bowl, this is our flask, this is our measuring cylinders. Delivery tube is this one here that goes all the way from this side to that side. Okay, so the final stopcock, it should be this one. The stopper is this one right here. Sodium, hydrogen, carbon, and okay, and sodium, hydrogen, carbonate powder, and dilute sulfuric acid. So these are our components for this experiment. Okay, so number one, we have to, they say weigh 20 grams of NaHCO3 and place it in a flask. Set up the above experiment, which is what we have right here. Okay, and then you measure out of 5 milliliter of H2SO4 and carefully pour this into the funnel and make that the stopcock, make sure that the stopcock is closed. Okay, slowly add H2SO4 to the NaHCO3 by opening the stopcock. So you observe what happens thereafter, and then you record the volume of gas collected in the measuring cylinder, excuse me. So you repeat the above step, but this time use 10 milliliters. So you keep on increasing to see the maximum amount of substance that can be added into the solution, right? So you write a balanced equation from this reaction. The hint is the carbon dioxide gas is formed as well as water and sodium sulfate. So results in discussion. You should observe that more gas is formed when using H2SO4. Okay. So it's just a short experiment. So these are experiments that you guys will get to do once you get to class, because there's many things that prevent you from actually doing experiments. But these ones, it's how you do experiments that help you to measure the relationship between the product and the reactants. Okay. So we're getting to the chapter summary of this chapter. It says here, a chemical equation uses symbols to describe a chemical reaction, and we've already established that through the stuff that we've spoken about. That a chemical reaction uses symbols to describe a chemical reaction. For example, H2, like hydrogen gas, we say it's H2. That is an example of a symbol that is used to describe a chemical reaction. So you've got your one side, which is the reactant side, then you've got the arrow in the middle, which actually represents the reaction taking place, and you're going to have another symbol after that to represent your product. So it's going to be AB will give you A plus B will give you AB. Okay. So your A plus B will be your reactant and your AB will be your product. So in a chemical equation, reactants are written on the left-hand side of the equation and the product on the right-hand side. The arrow is used to show the direction of the reaction. Okay. So if you had to point your arrow in the opposite direction, it would mean that what you have on your right is your reactant, and what you have on your left is your product. So basically, the arrow is the direction of your reaction. Okay. So make sure you remember that, guys. It's very important. So when representing chemical change, it is important to be able to write the chemical formula of a compound. Okay. The chemical formula, you know what that is? H2SO4 is a chemical compound. Is a compound, right? Is a chemical formula of a compound. So when you're representing chemical change, it's important that you're able to write it properly. And sometimes it can be difficult because of the naming and the wording, but it's very important that you write it correctly. Otherwise, whatever you're going to be balancing is not going to be what you were asked to do. Okay. So it says here, the law of conservation of mass states that the mass of a closed system of a substance will remain constant regardless of the processes acting inside the system. Matter can change form, cannot be created or destroyed. Remember, guys, we've been about the law of conservation of mass. We also spoke about it earlier in the other chapters where we said that a closed system of substances will remain constant. So whatever happens, okay, matter cannot be created or destroyed. It could only be changed from one form to another. So it cannot be destroyed and it cannot be created. So it's something that's just already there. You can only manipulate it to change it from one form to another. So in any chemical change, the law of conservation of mass applies. This means that the total atomic mass of the reactants must be the same as the total atomic mass of the product, which is what I've already explained, that we can change the number of moles to make sure that each substance on your reactant side is equal to the substances on your left-hand side. And how we do that, you can even test it out and calculate the grams and multiply with whatever. For example, if you have a 2 in front of the compound, or you have a small letter 2 on your H, by multiplying that with the number of grams, and finally they have to be equal. Even if you don't calculate them using a calculator, but just writing down what you have, they must give you an equal ratio. Okay, so this means that the total number of atoms of reactants must be the same as the total number of atoms in the product. So if the number of atoms of each element in the reactant is the same as the number of atoms of each element in the product, then we have a balanced chemical equation. Okay, so that's what that means. So if the number of atoms of each element in the reactant is not the same as the number of atoms in each element in the product, then the equation is not balanced. So this chemical reaction is basically void. We're not reaping the result that we were looking for. Okay. So in order to balance an equation, coefficients can be placed in front of the reactants and products until the number of atoms of each element is the same on both sides of the equation. So the state of the compound in a chemical reaction can be expressed in the chemical equation by using one of 4 symbols. The symbols are G for gas, L for liquid, S for solid, and AQ for aqueous solution. So this one, it's also important that you know how to write the state of your compound. Okay, so you need to be able to also write the state symbols, so you know, okay, this is gas, that's a liquid, gives you gas or aqueous, etc. So these symbols are written in brackets after the compound. So it will be important that you know how to place them as well. And you always know, because they'll always say, for example, gas, they'll always say, for example, nitrogen gas, then you know it's a G. Or they say that a liquid solution or liquid hydrogen, water, etc. And the AQ, they like talking about solutions. For example, H2SO4 solution, then already you know this is an aqueous solution. Okay. And solid will always tell you that it's a solid. So when you write your balanced chemical equation, it must be balanced and it must also have your state of the state of the compound or the or the element. Okay. So you also need to have that in check. So these are some revision questions. So it says on number 1. Okay, now let me just go to the. Okay, okay. Start with number 1. It says propane is a fuel that is commonly used as a heat source for engines at home and homes. So balance the following equation for the combustion of propane. So this is the equation for combustion of propane. So another interesting fact that you must know is that in a combustion reaction, our product is always carbon dioxide and water. So this is proof that this is a combustion reaction. So methane or propane, balance the following equation. So our equation here, let's see what is happening. We've got CH8 and O2 gives you CO2 plus H2O. So now we need to balance these two out. So we have 8, we've got 8 hydrogens and we've got 2 hydrogens here. So already here, we need to put in a 4, okay? And then on the O, and here we need to put in, I think we also have to put in a number in front of the carbon dioxide. Normally we can try a 3 out because it will give us 6 plus 4, which will be 10. And here we'll put in a 5. But let's check it out. So here we have it, right? So if we count the product in each element, the product you can find, the reactants, carbon is 3, hydrogen is 8, oxygen is 2. On the product, C is 1, H is 2, and O is 3. Remember, guys, it's very important that you write each and every element and how many atoms they've got in order for you not to be confused, especially when it comes to longer equations that are difficult, you know, to keep track of how much is this. So, like I told you guys before, what's best way to do this is to do it one step at a time. First, you tell yourself, okay, I'm going to balance out the hydrogen because there's 8. I just put a 4 in there, right? And then you write it down. You write it according to this again so that you can see now what is the next thing that you have to balance. Then now we decide we're going to balance the oxygen because we're going to balance the carbon because there's 3 and here we've got 2. So we put a 3 there and it becomes 6, right? And then now we've got, it's balanced aside, but now we've got an excess of oxygen. So there's 10 oxygen now. What do? Now you can at last balance this out with whatever the total oxygens are on this one. Okay. So as you can see here, in order to balance the number of C atoms, we change the coefficient of CO2 to 3. We also change the coefficient of H2O to a 4. And the coefficient of oxygen to a 5. So now this becomes our chemical reaction. Okay. So now everything is balanced out. So the one that has only one element, you can balance it last. Why? Because with these ones, it will always be uneven ratio. So you always start with the ones that are in compounds. You first balance those ones out, and then at the end, whatever element is standing alone, you can balance it with whatever number you have on your product side. I hope that makes sense. But if it doesn't, you guys can send me a chat and I'll explain it again. Okay. Then we're moving on to number 2. Guys, can you please switch off your mic? I can see there's a mic that is open. Thank you. So moving on to number two. Number two says methane, which is CH4, burns in oxygen according to the following reaction. Okay, so this is our reaction. So number A, they say complete the diagram. Complete the diagram by drawing ball and stick models of the product. Okay, very interesting, isn't it? So now you're going to use a stick and ball, a ball and stick model for your product. Okay, so you complete the diagram by drawing. So methane burns in oxygen. So this one is going to be methane CH4 plus O2. And what does that give you? Okay. So what does that give you? So this is how you would be able to draw it. This one is your CH4. So here it should be an H, an oxygen, and these are your two H's. And this one is your CH3. Okay. So this one is a bit tricky because they didn't write it out. What is your chemical reaction? So you just assume, but these ones are your O atoms, and these small ones are your H atoms. So here it's going to be um, C2H, right? So this is going to be your C2H plus um, this is oxygen, it's O, H2O. Okay, this is water. So this is H2O because you see there's two H's. They are the small ones, and then this is your oxygen molecule. Okay, so it's gonna be O and the two H's, and in this case, it's gonna be the C and the one H. So it will still be balanced out. So you still have to balance it out, but here they just want a stick model of how the product would be. So our product in this case is going to be C2H plus H2O. Okay, now this is carbon dioxide, CO2. So in this case, the O's, this is the CO2, and these are the two oxygens. Yeah, because remember, guys, once the minute they mention burns, they're talking about a combustion reaction. So we know the results of a combustion or a burning or fire, etc. Our result will always be CO2 plus H2O. So that's why it is that they didn't name them here, but you should know. Okay, so it still would have to be balanced out, but it's not at the moment. Okay. So now we move to number three. Number three says chemical weapons were banned in Geneva Protocol in 1925. According to the protocol, all chemicals that release suffocating and poisonous gas are not to be used as weapons. So white phosphorus, a very reactive allotrope of phosphorus, was recently used during a military attack. Phosphorus burns vigorously in oxygen. Many people got severe burns and some died as a result. So the equation of this spontaneous reaction, so this is like an explosion reaction, okay? Now they ask us to balance the chemical equation, right? So you've got P4 plus O2 gives you P2O5. So the first step we're going to do, we need to balance out our P, and we can just put a 2 in front there. If you put a 2 there, it's going to be P4 and O10, right? And then thereafter, we're going to put a 5 there. Remember, These ones, because they're much simpler because they are one element each. So it's not very complicated to balance it out because you first balance the first one, and whatever total number you get from your product side, you're just gonna balance it out on the other element. Okay, because if your oxygen is 10, then we know we can just add a 5 over here. Okay, then you've got 10. Then our equation is balanced. As you can see here, the solution. Okay, you see it's going to be P4. We put it here to make P4 and P4. But if we check here now, our oxygen is a 5 at times 2, it gives us 10. So we just add a 5 in front there. Okay. So number B, they say prove that the law of conservation of mass is obeyed during this chemical reaction. So it says here, by looking at the balance equation, we can see that there are the same number of each kind of atoms on both sides. Okay. So what does that mean? It means that there is no atom or there's no atom that was lost during this reaction. So that's why it says that it's obeying the conservation of mass. So there's no atoms that were lost because the amount of reactant is equals to the number of atoms in your product side. They might have been bonded in different ways, but they still the same amount. So adding up the mass on the left-hand side and comparing it to the mass on the right-hand side gives you the same number. So the law of conservation of mass is being obeyed. Okay. So name the product formed during this reaction. So it's phosphorus because this is a P. Phosphorus pentoxide. Pentoxide, pent because it's 5, and oxide because it's oxygen. Okay. So it's phosphorus pentoxide. Okay. So now they want to know, classify the reaction as a synthesis or a decomposition reaction and give a reason for your answer. So what kind of reaction is this, guys? This is a synthesis. Two components combine to give you a new compound. Remember when we spoke about decomposition and synthesis reaction? We said that decomposition reaction is the one where you have one body and it breaks down into small pieces. So it would be, for example, PO gives you 3 plus O. And then for a synthesis is one way you build one structure. So it's small pieces making up one big structure. And that is what we call a synthesis reaction. Okay. So I hope that all makes sense to you guys. And I think that we can cut these problems for today. And we can continue tomorrow, guys, with the problems. Okay. We're going to continue tomorrow. But I think we can do this number 4, right? Let's do number 4, and then we can cut it for tomorrow. I'll also give you some of the questions so that you guys can go and also practice it out. And tomorrow we're finishing up our revision. Okay. So the following diagram represents the combustion of ethane. Complete the diagrams and write a balanced equation for the reaction. I also indicate the state. Okay. So this is what we have here. All right. So this is how they balanced it out. Each one here started to bond with one of these. So this one also broke down. And they formed 2 of them were forming with each, and this one was also forming with these ones. So they rearranged themselves. So this is also a step in chemical equations. During this part, remember the bonds break on this side to form new bonds. So this is what basically happens. Okay. So the balanced equation would be C2H6 plus O2 gives you CO2 plus H2O. Remember, combustion reaction, so you get carbon dioxide and water. But thereafter, we need to balance the chemical equation. And you know how we do that. So here it's already been done. So guys, I hope that all of that makes sense to you guys. For now, let me see. So these are the problems that we're going to be doing tomorrow. You guys can write them down quickly if you don't have them. And it's going to be number 5, number 6. So we're going to be doing number 5, number 6, and number 7. So you guys can write them down quickly, and you can go practice them for today, and we'll do them tomorrow in the beginning of class. Okay, number 7 and number 5 and 6. Okay, so we're very much close to the end, and I think that once we're done, we'll go back to we'll then move to um, we'll move to term 4 after the assessments. It's only fair, guys. We need to really push hard. Thank you guys so much for this lesson. If you have any questions and queries, t32@gmail.com is my email address. You can get me there and you can ask any questions with what we are doing so that you guys can better understand. At the end of the day, the most important part is understanding the work. As much as we push in the syllabus, but you guys need to understand. So if you don't, guys, just always let me know and we'll be good to go. Thank you guys so much for your lesson and goodbye.